Hi, let's take a look at the one-dimensional equation of motion. This is the equation that tells us where an object will be at any given time in the future. If you went through the module, you would have derived this equation using some basic definitions of position, velocity, and acceleration, along with a little integral calculus. Assuming we're in the x direction, which we can make as the default horizontal motion, we ended up with an equation that looked like this. We had x equals x naught plus v naught t plus 1/2 at squared. On the left we have x. Sometimes we call that the final position, but really it's just our position as a function of time. On the right we have three terms. Each one adds a certain something to the equation. The first one is the initial position term. That tells us where the object was located when t equals 0, or when we started the analysis. So if our object is not located at the origin, we expect to have something there. That's one of two initial conditions, we call them. The second one, the initial velocity, represented by v naught, likewise tells us how fast the object was moving when t equaled 0. So if it had some velocity when we started the clock, we would expect that term to be not 0 either. The third term, 1/2 at squared, contains our acceleration. So if our object is changing its velocity in any way, we expect that to also be non-zero. The three of these, after properly evaluated, add them all up, and then that tells you where the object is going to be at any given time in the future. Part of the art of problem solving is turning the words in the problem into these various terms. Next up, we'll take a look at how to do that for some cases.